Okay, so we're on 5.4, but we're going to skip over this warm-up here. You can definitely try it out, but for the sake of time, I want to make sure we come to the actual notes part. This warm-up, when I did it, I got to about 8 steps when I was trying it out, but I'll look it over and see if there's a quicker way to get to that eventually. But let's go down here to the bottom where we're talking about properties of rectangles, rhombus, and squares. And so there's a quick exploration. It is similar to what we did when we first started 5.1 on Tuesday, where we talked about, okay, here are the different triangles that we could take and try to rotate it or reflect it, different transformations that we could take. So this first one says to rotate triangle ABC. This is triangle ABC, and it is a right triangle. This is a scalene right triangle. So just to be specific here, that's what's going to create this figure. And we are rotating it 180 degrees about the midpoint of its hypotenuse. So let's say that's the midpoint, and this is our hypotenuse because it's across from the right angle. And if we go to rotate it 180 degrees, you can kind of see how it's going to start. You can almost flip your paper upside down if you want to see. That's going to end up matching up with that hypotenuse. Okay, so if you have tracing paper, you could of course use that, or if you want to just try your best with graphing it like I will. You're going to get all the way across like this, and then straight down. So that this leg here matches this one. Because remember, when you do a rotation, it's still in isometry so that none of the side lengths or angles change. And then same with this bottom part, BC, it's now going to be the same at the top. I can label this point D, just so that we have a way to name this parallelogram. And now the parallel, or I'm sorry, it's not a parallelogram, but we'll talk about its shape in just a second. A, B, C, D, and remember the angles stay the same, so if there was a right angle in this corner, there's also one now in the top corner for D. So when it says to classify the quadrilateral formed by the two triangles, we're going to see how we got it. So when we're at this point and we're trying to figure out, so far I have 2 right angles. If you think back to on Tuesday when we talked about 5.1 was just exploring all the different shapes, a rectangle had 4 right angles and still has the same criteria as a parallelogram, where it has 2 pairs of opposite sides congruent. It also would have 2 pairs of opposite sides parallel, and then all the same things would be true as what it is for a parallelogram. But right now I only see 2 right angles, but I'll show where the other 2 right angles would come from. But let's go ahead and first write down that this is definitely a rectangle. And the reason why it is a rectangle, let's go ahead and see where those 4 right angles come from. So remember, if you think of the angle measures, that angle right here that originally angle A started off as, when I go to rotate it, now it's down here. Also, you can notice those are alternate interior angles that are going to be congruent because the lines are parallel. Same for this pair here, the part that we just drew here with the original angle C. Okay, those are going to match as well. Now, without knowing what the angle measures are, if this angle here is 90 degrees, that means the other 2 angles have to add up to 90 degrees as well, because think of the sum of the triangles have to add up to 180, take away 90, and you're left with 90. So those 2 together have to add up to 90. Well, that's what exactly these 2 are. So there is a right angle here and here. Hard to see because I had to draw it kind of big, but there's 4 right angles here. 4 right angles. That would be the reason or explaining how I got to my answer that this is a rectangle. Started off being a scalene right triangle, and then I rotated it 180 degrees, and it turned into a rectangle. Okay, now that we have a rectangle here, we're going to write down some important characteristics. So first thing I have here is, let me try to draw in the diagonal, and I'm going to do this in another color so that you don't get it mixed up with all the other parts here. But here's the other diagonal, and we already know that from this diagonal, the diagonals do still get bisected because of the fact that a parallelogram or a rectangle is a parallelogram. So we could still mark it with those congruent signs, but before you do that, let's look carefully at what this segment is. So since A to the midpoint, and you could call that whatever letter you want, and then to the midpoint to C, those would be the same because it's a midpoint. If I was to measure the distance from B to that same midpoint, it would be the same as going from the midpoint to letter D. And so what ends up happening here is that the diagonals here, they are actually congruent. So I'm going to write that here. Diagonals are congruent. So specifically, the diagonals in this diagram are AC is congruent to BD. Those are my two diagonals, and in every rectangle, this will be true. The diagonals are always going to be congruent in a rectangle, and so this says, what conclusions can you draw about the angle measures, the side lengths, the diagonals of the rectangle? So far we have the diagonals are congruent. We also already knew the 4 right angles part, so if I want to write down that angle A, B, C, and D are right angles, you could definitely mention that as well, just to be specific, or go on to say the measure of angle A equals a measure of angle B equals a measure of angle C equals a measure of angle D, which is 90 degrees. You don't have to include all these details, but that would be true if we had right angles. Now, the only other details that we could include here are all the properties of parallelograms, because those would also hold true for a rectangle. Because remember the flow chart, the parallelograms at the top, rectangles below it, so anything that's like its child, basically, it's holding all the characteristics of the parent. And so I don't want to write all of them down here, but I'll just write parallelogram, properties, and definition, also true. So it has to have, if I want to include it in my diagram, I could include the 2 pairs of parallel sides like that with the little arrows, right? I could also include that the diagonals are bisected, but here's something you want to keep in mind now. If the diagonals are congruent in a rectangle and the diagonals are bisected because they are a parallelogram, these segments are all actually the same. So that's what's different for a rectangle versus a parallelogram. A parallelogram only had one diagonal that was split in half, and then same for the other one. They weren't all the same value. Here, for rectangles, you're going to have the same number for all 4 of those segments. Okay, so you could go on to say segment A, let's call it M. AM is congruent to CM, is congruent to DM, is congruent to BM. If you want to write that part down, you could, but we'll keep that in mind as we get through some more examples. Okay, so now that we have it, we're going to kind of summarize all this because I wrote a lot here, but this is a nice quick summary. It's in a little box here so you can come back and look at it really clearly. The first 6 are all the stuff that we've already covered with parallelograms. So let's do a quick review of properties of a rectangle. Summary. And although it starts with being parallelogram stuff, it's going to eventually get to the rectangle part down here. But right now for the parallelogram stuff, because a rectangle is a parallelogram, we're going to just kind of review this top part. So if it's a parallelogram, then both pairs of opposite sides are parallel. If it's a parallelogram, then all pairs of consecutive interior angles are supplementary. If parallelogram, then both pairs of opposite angles are congruent, and both pairs of opposite sides are congruent. And finally, well, the one that we'll stop at this one, but I'll add number 6. Number 5 is the one we kind of were saying of the 4. The diagonals bisect one another. Now, number 6 is there. We just don't use it on a proof, but it's also true that anytime you have a parallelogram, the sum of the measures of the interior angles is 360 degrees. That was something we saw. Remember that foldable that we made, that yellow one, back 2 days ago. So the last 2, though, are what's new about rectangles now. So we want to say if rectangle, then 4 right angles. And if rectangle, then the diagonals are congruent. So there's a lot here, but the nice thing is you are allowed to use your yellow packet throughout the whole quiz and test. And so you'll hopefully have a way to remind yourself of these things if you forget. Like a lot of times students will get mixed up with rhombus and rectangle and like deciding which one has the diagonals that are congruent. Well, this sheet can tell you. So if you want to double check where it all is, it's going to be right towards the kind of the middle or the bottom, towards the bottom, but it says if parallelograms with, with diagonals congruent then rectangle, or if rectangle then diagonals are congruent. So it says all of the properties right here. The original definition for rectangle, though, is going to be at the top. If parallelogram is a rectangle, then 4 right angles that we saw earlier this week as well. So it's all in here. You can always come back to that. Okay, so the next shape that we're about to see is a rhombus, but it says, here's how we get it. We are reflecting this triangle ABC over its base. This triangle is an isosceles, specifically acute triangle, you could say, but you could technically use a different type of isosceles triangle and it probably still would be okay. But it's going to reflect it over this base, BC. So when we do that, just try your best to draw the same. It helps if you have like a ruler just to measure the exact legs, but they're still going to be congruent, and we'll label this point down here D. So it goes, this rhombus is ABDC. So make sure you're careful with the order that you're reading it, or ACDB is fine too. If we were to name it, that's what it could be. But let's see what, so this is going to be a rhombus, and let's see where that comes from. Remember that the definition that we saw back on Tuesday, and it's right in this top part here, if parallelogram is a rhombus, then 4 sides congruent. And that's exactly what we just saw here. 4 sides are congruent because when you go to do a reflection, it's an isometry, so all the side lengths stay the same. So this is a rhombus because you have 4 congruent sides. That's how we kind of got to our answer. Now, in addition to having 4 congruent sides, though, a rhombus has more. So we already have one diagonal drawn in here. Let's draw the other one. Okay, now notice that my diagonal, the way I've drawn it like this, hopefully helps you to see that these 2 diagonals are perpendicular. And they always will be. Sometimes the rhombus won't be drawn this way. They might be like shifted. And so it'll be harder to see vertical and horizontal lines. But this one, they want you to realize that it is perpendicular. That's why it was drawn this way. And so these are always going to be perpendicular. That's what we're going to write down here. The diagonals are perpendicular. And specifically, that means AD, segment AD is perpendicular to segment BC. And this is for a rhombus. So we are trying to see what else can we conclude. We already had the 4 congruent sides, if you want to write down what those sides are. So AB is congruent to BD, is congruent to DC, and it's congruent to AC. You can put those in any order you'd like, but those are all 4 of them. So we have diagonals that are perpendicular. We obviously have the 4 congruent sides. There's actually one more property for a rhombus. Let's see if we can find it just by looking at the diagram. So the difference here is, remember the base angles theorem for triangles that are isosceles? So like that would be the same. Well, if these are all the same triangles, when I go to reflect it, remember it's the exact same measure, so this measure comes down here, and this one also comes down here. What do you notice about these angle measures? So like angle B has been then bisected, right? It has been like divided into 2 congruent parts. Same thing happens up here for angle A. That'll get divided into 2 congruent parts, and so same with D. But remember, opposite angles are still congruent because this is a parallelogram. So like let's say angle A is 30 degrees, angle D is also 30, but now you know that if I split, once I draw the diagonal in, that splits into 15 and 15. That's not the case for every parallelogram, though. We saw that with parallelograms, there were different numbers sometimes. This is only true for rhombuses. Okay, so we'll write down here that the diagonals bisect the opposite angles. Okay, and so we'll add that also in our details here in just a second. But so far, those are the properties. The new ones are, again, diagonals are perpendicular, and the diagonals bisect the opposite angles. The definition was already that a rhombus has 4 congruent sides, so we have 2 new things to kind of keep track of or remember as we think about rhombus. So let's kind of summarize here. It says, what are these properties of a rhombus now? It starts off with everything that's true for a parallelogram again, because those are also true for this rhombus. So they still will have both pairs of opposite sides congruent, or sorry, parallel is what the first one was. So if you want to draw in the opposite sides parallel like these 2 and these 2, you could absolutely do that. Everything does not have to always be drawn in, though. It's understood that some things are not drawn, but they're still true. And then the consecutive interior angles are still supplementary. So whatever the angle measures of, like, if A was 30 degrees, then B would have to still be 150 because they have to be supplementary in every pair of those. Opposite angles are still congruent as well. Like I said, if angle A was 30, then D would be 30. But it's just that once you draw the diagonal, you're just splitting them up into congruent pieces. But this part where it says, if parallelogram, then both pairs of opposite sides congruent, that's absolutely still true, but it's more accurate to just say 4 congruent sides, because not only are the opposite sides congruent to each other, they're all congruent to each other, all 4 of them. And so that's kind of what's different from a parallelogram versus the rhombus. So almost done here with this one. The diagonals bisect one another. So again, I could write that here with these little tick marks if I want to. But notice now that the diagonals are not congruent. So that's why I'm using the 3 tick marks for these two, for example, and then the 2 tick marks on the other diagonal. Because it's not like a rectangle where rectangles are congruent diagonals and the diagonals have to bisect each other. This is just diagonals bisect each other just like it did for a parallelogram. All right, and then the last one before we get to the new ones are 360 again. 360 degrees for the parallelogram's sum of interior angles. Okay, and then the last 3 will now say if rhombus, then 4 congruent sides. If rhombus, then the diagonals are perpendicular. That means they will create 90-degree angles. And if rhombus, then the diagonals bisect each pair of opposite angles. Okay, and that's going to be it for a rhombus. All right, the last one asks a different type of question. It says, in order to create a square, so now that's our last shape, what type of triangle would we transform, and how would you transform it? So we did do this on Tuesday. For a square, we had to use an isosceles right triangle. Because isosceles means the 2 sides are the same, so that similar to what we just did for rhombus, when we go to rotate it or reflect it, it will remain that the sides are still the same and you get 4 congruent sides. But because a square also has 4 right angles, we have to use the fact that we have a right angle there. Okay, so let's try to draw a right triangle, an isosceles right triangle, something like this. Legs are the same and the right angle. Now, if looking at that triangle, we could do one of 2 things to try to get it to be a square. You could either rotate this triangle about the hypotenuse, so that you start rotating until it hits and kind of gets right next to the hypotenuse with the other hypotenuse matching up. Or you could reflect it also, and that would be fine. Either way, it's going to look like this. Not the best diagram, but hopefully you see that we so far have 2 right angles drawn in. And for my explanation here of the transformation, I can say either reflect over the hypotenuse or rotate 180 degrees about the midpoint of hypotenuse. Okay, so there's my square, and the reason it is a square, again, in case you don't realize where the other 2 right angles are, if you were to think about these alternate interior angles of the original, and then these 2 would be something different. Remember, they have to add up to 90 because that's what's left over for a triangle, and so there are 4 right angles here. Okay, so we can write down, actually I'll write that on the next part, all of the different properties that a square has. We'll start with what we see in the diagram first, that we have 4 congruent sides and 4 right angles. Okay, so notice both of those characteristics came from a rhombus had 4 congruent sides and a rectangle had 4 right angles. So it kind of took each of those properties. That's what kind of defines a square. If you look at this definition of a square, it says it right here. If parallelogram is a square, then 4 sides congruent and 4 right angles. So both things have to be true for it to be a square. But now that we have a square, all the other properties are true too. That you have diagonals that are congruent, diagonals that are perpendicular also, because that's what came from the perpendicular came from a rhombus, and the rectangle gave me that it's congruent. And then the diagonals also bisect each pair of opposite angles, like we just saw for a rhombus as well. So far I mentioned the definition part of the square, the rectangle's property as well, and then onto the rhombus's property. The only thing missing now are all the parallelogram properties. So we have diagonals bisect one another. We have opposite angles congruent, which obviously would be the case because you have 90-degree angles. So I'm going to almost put that in parentheses just because it's kind of repetitive, because we know we have 4 right angles, so obviously the opposite angles would be true, would be congruent. Same for opposite sides congruent. I'm going to put that in parentheses too, because yes, it's true because it's a parallelogram, but technically you have all 4 sides congruent. So you have even more detail than just what a parallelogram had. And finally, consecutive interior angles supplementary. Oh, I forgot to include the definition also. Opposite sides parallel. So I do like to include the opposite sides parallel because you could draw in your alternate interior angles that way with the diagonals and see that they are going to be congruent because they're alternate interior from this piece. All right, and that's where we stop.